So let's first of all look at the word trigonometry. What is trigonometry? Can anybody tell me?
Science of like triangles.
Yeah, good.
Study of triangles.
It is the study of triangles. How do you know? Let's look at the words. Try, what does that bit mean?
Triangle.
It means three in general, right? Think about a tricycle, it's got 3 wheels, okay? What does the gone bit mean? Anybody know? I can think of a word which is got a gone in. Polygon. The gone bit is just the Greek word for an angle. Okay, it's just the Greek word for an angle. In that case, polygon, poly means many. So a polygon would be a shape which has many angles in. For example, something like this. Yeah, that's got many angles in. So polygon is just in general a fancy word for a shape. But yeah, that just means angled. Okay. What does the ometry bit mean? What does the ometry bit mean? Now, the ometry bit is actually a suffix, so it means it comes on the end, okay, as opposed to a prefix, which comes at the beginning. Right, I could say, ometry, or I could say ography, or I could say ology, okay? All of these things are related to the study of things, okay? For example, obviously you've got trigonometry, you could have geography, which is the study of the land, okay? You could also have geology, which is the study of rocks within things, or psychology, or sociology, okay? They're all related to studies of things, okay? But the ometry is kind of related to a word which I think you already know, which you already know. Can anybody think about it? What does it sound like? Metric. Yeah, we've all heard that before. What does metric mean? It literally just means measure. Okay? So if you talk about metric, it literally is just a measure of something. Okay? So for example, a metric could be how far you can see. It's just a measure of how far you can see. Okay, so metric just means measure. So in this case, the ometry bit just means measure. So the word trigonometry literally means the measure of 3-angled objects. In other words, triangles. Yeah? Good, so it's related to triangles. So let's think about this. Specifically, it's right-angled triangles. But you say, well, hang on a minute. Why do we just have to keep ourselves to right-angled triangles? Like, why are we so interested in them? Well, are you happy that I can draw any triangle I like? In fact, you can do this yourself. You can draw any triangle you like. And would you be happy that every single triangle can always be broken up into right-angled triangles? Okay. Just by drawing down a perpendicular, I've now got 2 right-angled triangles in there. So if I talk about right-angled triangles, I'm actually talking about every single type of triangle that you can get, because you can always split it down the middle. You can always put your perpendicular in there and create 2 right-angled triangles. Okay? And in fact, by talking about all types of triangles, I'm also talking about all types of shapes. Would you be happy? So for example, if I draw something like this, what type of shape would that be?
Hexagon.
It's a hexagon, right? Because there's 1, 2, 3, 4, 5, 6 sides, okay? And would you be happy that I could also break this up into 1, 2, 3, 4 triangles, okay? So every shape consists of triangles. So if I'm able to talk about right-angled triangles, I'm talking about all types of triangles. And by talking about all types of triangles, I'm also talking about all types of polygons, except those with curved edges, but we'll exclude those for time being. Does that make sense? So trigonometry is an important measure. Okay. So let's think about this. Could you make a copy of this for me? So could you make a copy of this right-angled triangle here? In fact, could you make a copy of each of these triangles here? Now these 2 triangles, in fact, they don't look that identical. Let me just quickly redraw this one. But they are identical triangles. Okay. That's a bit better. Okay. But what's the difference? What's the difference? So imagine these two identical triangles. What's the difference between this one and this one?
They're identical, there's no difference.
Yeah, exactly. There's no difference. But what I'm trying to say here is that there's two angles which I'm interested in. There's this one. There's this angle and this angle here. Because are you happy that one of the angles is already 90 degrees, which then leaves two angles which I'm interested in? If one of them's taken, I've only got two angles left. Okay. Now, the way which I would label up the sides in each of these triangles would be in relation to the angle which I'm looking at. So if I'm looking at this angle down here, the sides would always be called or named in relation to this angle. And likewise, in this triangle over here, the sides would be labelled in relation to this angle. Okay? So let's see how good we are. Where would the hypotenuse be? Here, here, or here?
It's in front of, it's the opposite of the right angle.
Good. So this side over here will be the hypotenuse. I'll just call it HYP for short. Okay? This would be the hypotenuse. Where would the hypotenuse be in this triangle over here? In exactly the same place, right? So the hypotenuse doesn't change regardless of which angle I'm looking at. Okay, it doesn't change. But there's also two more sides, and the sides are always named in relation to the angle. So can anybody tell me what would this side be?
For that angle will be the opposite side.
Good. And why would it be the opposite, Ahmed?
Because it's opposite. It's facing it.
Exactly. If this is the angle which I'm interested in, this is the side which is opposite that angle. Okay. What would this side be down in this triangle? It would be the opposite, right? Because again, it is opposite this angle here. So you notice that the opposite changes sides depending on which angle I'm looking at. Does that make sense? Okay, what would we call this side here?
Adjacent.
We call it the adjacent. Good. What does adjacent mean?
It means it's next to it.
Exactly, it means next to, right? And you can see it's literally next door to it. It's literally next door. And would you be happy that on this triangle, this must have to be the adjacent, because that's the side which is next to that angle. Okay. So far, so good? No issues? So the side the way which we name our sides in a right angle triangle depends on which angle we're looking at. Okay, but the hypotenuse, you notice, doesn't change. It's just the opposite and adjacent. Okay. Now, what is a ratio? What is a ratio?
It's like a division.
It is a type of division. Yeah, you can absolutely think of it as a division. But why do we call it a ratio, and why don't we just call it division, for example? What is a ratio? A ratio is just simply a type of mathematical comparison. Okay? It's usually a comparison of sizes. Okay. So for example, you could write a ratio like this, 2 to 1. 2 to 1. Okay. What that would mean is that whatever this side corresponds to, it's twice as big as the right-hand side. For every two things that we have over here, we've only got one thing over here. Okay. But more generally, a ratio is just a comparison of sizes, right? And you're right, you usually write a ratio either with two dots, but you can also think of it as a division as well. Now, would you be happy that there are three sides in a right-angle triangle? So how many comparisons can we make between the sides?
3.
3. Okay, we can either compare, in fact, let's write this down, the opposite and the hypotenuse. Okay, so we could compare the opposite and the hypotenuse. That would be my first ratio. That would be my first ratio. What else could we compare?
Opposite of adjacent.
Yeah, opposite and adjacent. That works. What else can we compare? Absolutely right. Okay. So these are the three comparisons we can make. Either the opposite and the hypotenuse, or the adjacent and the hypotenuse, or the opposite and the adjacent. And in fact, because these are so important, because we're literally dealing with all of the different comparisons we can make in a right-angle triangle, we give them their own special names. Okay? Does anybody know what is the name that we give to that first comparison, the opposite and the hypotenuse?
Sine.
It's sine, yeah, good, which we usually abbreviate to SIN. Okay, it should be SINE, but we abbreviate it to SIN. So that's our first comparison that we can make. What would we call the comparison or the ratio of the adjacent to the hypotenuse? Yeah, good. Cosine, which we can abbreviate to cos. Okay, And what would we call the ratio of the opposite to the adjacent? The tangent, yeah, good. Okay. Now, clearly, we've said that the opposite and the adjacent changes or switches depending on which angle we're looking at. So therefore, we need to give each of these ratios in terms of which angle we're looking at. We need to tell whoever's reading this what angle we're looking at. Okay. So in this case, I'm just going to stick my angle as alpha, but you can call it whatever you like. Okay. So in this case, I've done it in terms of this angle, but would you also be true that it would be true for the beta as well? Yeah? Are there any issues there? So basically, when you give your ratios, when you give your trigonometric ratios, you always have to give it in terms of your angle.